In this video, we are going to study about dipole. I already said to you, an electric dipole is two equal and opposite charges separated by a very small distance. We say P is equal to one of the charges into 2A, where the distance of separation is taken as 2A. One is positive q, another is negative q, separated by a small distance 2A. So this is called electric dipole moment, which is a vector quantity, and Coulomb meter is its unit. And in the previous video 10, we derived an expression for the electric field of a dipole in the axial line. E is equal to 1 upon 4 pi epsilon naught 2p upon r cube. The variation we can understand is inversely proportional to cube of the distance, r cube. Usually it is r square, inverse square law, but in a dipole it is r cube. Today we are going to derive an expression for the electric field due to a dipole at a point on the equatorial line. Now where is the equatorial line? Okay, so this is the dipole, right? And this is the dipole axis. And if you take a point here, this is called axial line. But I am going to take in the equatorial line. In the equatorial line, somewhere here or somewhere here, I can find out what is the electric field due to the positive charge and due to the negative charge, and what is the resultant electric field. Now let me take the dipole to be like this, and the point is P is here, and this is in the equatorial line. The charge is plus q here, and charge is minus q here. And the dipole axis is 2a is the distance, and the middle point of is O. And from there, the point is lying P at a distance r from there. We know that this is a right angled triangle. So if this is A and this is R, using Pythagoras theorem, this is r square plus a square power half. That is, you will find that AP square or AP is equal to under root r square plus a square, which can be written as AP is equal to r square plus a square power half. So this is what the distance is. Since it is equilateral triangle, so this distance BP also will remain the same. The positive charge is influencing the electric field is E1, which is pointing outward. And the negative charge is the electric field is E2, which is towards the charge. Now, one charge is in this direction, another charge is in the other direction. Now, how do I find what will be the net electric field direction? Direction of the electric field. We use parallelogram law of vectors. Let us draw a parallelogram and complete it, and E gives us the direction of the electric field. Now, E1, let me take this point to be P, and let us say the point is X. In this triangle, right angled triangle, this is the base and this is the perpendicular. And what is cos theta? Cos theta is equal to base upon hypotenuse. The base, what we wanted to know, Px is the base we want, and this is the hypotenuse. Fine. And then we can write the base is equal to hypotenuse times cos theta. And what is this value? That is E1. So we can say this base is equal to E1 cos theta. In the same way, we move on further for E2. You draw again this equation. This distance will be equal to this distance. So this is E1 cos theta and this is E2 cos theta. Fine. So with this concept of cos theta and resolving into two components, we are going to find the value. Fine. Now we know that electric field is equal to 1 upon 4 pi epsilon naught q upon r square. What is E1 now? 1 upon 4 pi epsilon naught into one of the charges q divided by R is the distance between the charge and the point where you find out, that is r square plus a square power half. So r square plus a square power half into cos theta, right? So that is E1 cos theta. E1 cos theta is the value. So cos theta. Similarly, E2 is equal to 1 upon 4 pi epsilon naught into Q upon r square plus a square power half into cos theta. Fine. So these are the two values. We are going to now add them together. So E is equal to E1 plus E2, that is equal to 1 upon 4 pi epsilon naught is common in both. So let me write it outside, into Q upon r square plus a square power half is also common. Now what about cos theta? Cos theta, we found the value to be base upon base is equal E1 cos theta, the value to be equal to the cos theta value. We will take it from this figure, right? So R A is the base upon hypotenuse. So cos theta is equal to A upon r square plus a square power half. Okay, so let me take the value here, A upon r square plus a square power half. Okay, now this is whole square, Q upon r square. So let me put the square over here. Fine. So 2 gets cancelled. You have here E1 plus E2. So two values are there. So I can write it as 2 into this value. Fine. Now we already know that 2A into Q. What is 2A into Q? P. So I can write it as 1 upon 4 pi epsilon naught into P divided by r square plus a square power 1 plus half, 1 and half, that is 3 divided by 2. So this is the electric field of a dipole for a point placed in the equatorial line. Now we have to make a small change here. As I said earlier, if the distance where the point is there is very much greater than the distance of separation, we can put a condition R is very much greater than A, then E is equal to 1 upon 4 pi epsilon naught into P divided by A gets negligible value, R square power 3 by 2. 2 gets cancelled. So you get the formula 1 upon 4 pi epsilon naught into P upon R cube. This is the formula for the electric field due to dipole in the axial, in the equatorial line. Now let us compare this with the axial line. In axial line, the value is 1 upon 4 pi epsilon naught 2p upon r cube. And here in the equatorial line, it is just no 2 is there. So we can say from this axial line is here. So E axial is equal to 2 times E equatorial. Right? With this, we complete this video. Thank you so much.